Example 8. Given f of x is equal to 2x minus 3 over x plus 4, find f inverse. Give the domain and range of both f and f inverse. All right, so here we have another fraction to deal with. Okay, and like I did in example 7, I'm going to start off by finding the domain of the original function. Okay, so again, with a fraction, you have to worry about bad spots. What do I plug in for x that's going to cause me to divide by 0? Okay, so I'm going to come down here. Okay, I'm going to find my bad spot. I'm going to find my bad spot by setting the denominator equal to 0. Okay, so we're going to set x plus 4 equal to 0, okay, and solve that. My bad spot is x equals negative 4, okay. So we draw our little picture. Negative 4 is the bad spot, so I want to get rid of it with an open circle. Everything else is good. Okay, so the domain of the original function is going to be all real numbers except for negative 4. So it's going to be from negative infinity to negative 4. Throw it out with a parentheses, and then pick up on the other side of negative 4 and go off to infinity. Okay, so that is the domain of the original. Okay, makes sense. If we look at this, we plug in negative 4, we will get 0 in the bottom, so that would be bad. Okay, and immediately I know that this is also going to be the range of f inverse. Okay, so I'm going to go ahead and write that down. Okay, we don't have to consult a graph. All right, so now let's go and figure out what the inverse function is. All right, so first thing we're going to do, okay, change f of x to y. So I'm going to get y is equal to 2x minus 3 over x plus 4. All right, and then I am going to switch the x and the y. Okay, so I'm going to get, so everywhere, because this one's got a couple of x's, everywhere you see a y, you're going to put an x. Everywhere you see an x, you're going to put a y. Okay, so we're going to get x equals 2 times, instead of x, we're going to write down y, minus 3 over, instead of x, we're going to write a y, plus 4. Okay, and you've got to solve this guy for y. Again, can't emphasize enough. That means you need to make it look like y equals, and whatever's on the right side can only have x's. Okay, this one's actually going to be tougher than the fraction that was in example 7, because if you notice, now you have two y's floating around, and you have to isolate it to y equals. Okay. All right, we're going to do the same thing we did in example 7. We want to get rid of the fraction, so we're going to multiply by this denominator, okay? So in the next step, I'm going to take both sides, and I am going to multiply by the denominator, y plus 4, okay? So let me see here. We're going to multiply, use a different color. Where did it go? Okay, so multiply both sides by y plus 4. Okay, whatever you do to one side, you have to do to the other. Okay, remember y plus 4 is going to be a package deal. Okay, so you've got to use parentheses. Okay, we're doing this because you're going to end up with a y plus 4 in the top and 1 in the bottom, and they are going to cancel. Okay, so we're going to simplify. Remember, you can think of this as over 1 since this is all fraction-y over here. Okay, there's no fractions over here. Okay, so in the next step, okay, we're going to kind of clean this up, okay? You can multiply in either order, so I'm just going to kind of change it up here. So we're going to get x times y plus 4, okay? And I'm going to write out what I have on this side. To multiply two fractions, you need to multiply across the top and across the bottom, okay? Remember, this is a package deal as well. So it's all of 2y minus 3 times all of y plus 4. And in the bottom, 1 times y plus 4 is y plus 4, okay? And that's like a package deal, okay? And then what happens here is you end up with a y plus 4 divided by y plus 4. Anything divided by itself is 1. So this is going to cancel with this, okay? Like I said, you didn't have to go this far. You didn't have to do this step. You could have just canceled them here by noting that there's 1 in the top and 1 in the bottom. It's going to leave you with 2y minus 3, okay? All right. So that's what's going to be left on the right side, okay? And this is what we've got on the left side, okay? You are still trying to isolate y. Y is appearing on both sides, okay? Again, follow your instinct. Go ahead and distribute this stuff, okay? So we're going to get x times y plus 4 times x is equal to 2y minus 3, okay? Again, tougher than the last problem, okay? We've got y's on both sides, okay? So here's what we're going to do so that we can get y by itself. I'm going to put everything that has a y, so this guy and this guy, I'm going to put it on one side of the equation. And then everything that does not have a y, this guy and this guy, I'm going to put them on the other side of the equation, okay? So I'm going to move the 2y over, and it doesn't matter what you move to what side, okay? You just want everything with a y on one side and everything that doesn't have a y on the other side, okay? That is going to lead us to x times y minus 2y. I still have the 4x on this side, okay, equals to, these guys will cancel because you have a positive and a negative, negative 3, okay? Now, this has y, so that's cool, okay? But this guy does not, so he needs to be moved over, okay? So I'm going to move this over by subtracting 4x from both sides, okay? So now I'm going to get x times y minus 2y is equal to negative 4x minus 3, okay? And we've got what we want, okay? These both have y's, these do not, okay? We are still not done. It needs to look like this, y equals, with no x's on the other side, okay? So let's keep going, okay? Here's the trick, and this is what you want to remember, okay? This is how you're going to solve for y. The reason we did this, the reason we moved everything with a y to one side is now y is common to both of these pieces. So the trick is we're going to factor out a y, okay? We're going to write what's left, x minus 2. And you can check yourself. If you multiplied this back out, it would be x times y minus 2y, okay? That's equal to this. And the y is attached to this guy in parentheses through multiplication. It's y times x minus 2, which is a package deal. So all you have to do to free the y, and I'll write it in a different step. I don't want to confuse you. Okay, so in the next step, let me just rewrite what we have. To free the y, we are going to, since it's multiplied by this stuff, we're going to divide by it. Okay, so here is the inverse function. Negative 4x minus 3 over x minus 2. Okay, that is it. Okay, that is your inverse function. Okay, you could go ahead and write, here, I'll go ahead and write it down here. F inverse of x is going to be negative 4x minus 3 over x minus 2. Okay, so that's your inverse function. Okay, all I did here to go from here to here was replace y with f inverse. Okay. All right, so we got our inverse function. Last step is completing these fill in the blanks, okay? So here's my inverse function. I'm going to talk about its domain. It is also a fraction, so I need to think in terms of bad spots, okay? So the bad spot for f inverse, I'm going to take the bottom and set it equal to 0, because remember, you're trying to figure out what can I plug in for x and be okay. That's what domain is. So I'm doing this for this new function, okay? I'm going to take the bottom, set it equal to 0. That's going to give me my bad spots. So the bad spot here is 2, okay? Draw your little picture. You want to get rid of 2. Everything else is great, okay? So the domain of the inverse is all real numbers except for 2, okay? And then as soon as you write that down, you know that the range of the original function has to be the same thing. So I'm going to put all real numbers except for 2 in this blank. And that's it, okay? We started with our original function. We found its inverse. And then we have the domain and the range of both f and f inverse, okay? And remember, To get the ranges, you don't need to look at the pictures. You just need to remember the property that the domain of the original is the same as the range of the inverse, and the domain of the inverse is the same as the range of the original.